Hey guys, how's it going? Hope you're all doing well. Today's reaction video is a video from a YouTube channel called Destiny. Now, I've got to be honest, I've never heard of this one. This came up on my YouTube recommended when I pulled up YouTube. Probably because it's a similar channel, probably scientific channel, a similar channel to um Bright Side, which was another reaction, a previous reaction I did and posted on my channel. And this one's called Scientists Are Stumped. Saturn is changing and it's not good. Now, I do know, and it mentioned in the other video, the Bright Side video, that in the very distant future, Saturn is going to lose its rings. Saturn, as we know it, it's not going to have its rings because the rings are spiraling in towards the planet, and eventually they're going to collide with the planet and just disappear entirely. But, so he might mention that in this video. They might mention that in this video. I don't know. I've never heard of this channel. I've never seen this video. But it should be really good and interesting, as always. Let's see what we got.
Deep within the solar system, some 880 million miles away from Earth, a baffling world spins gracefully that has captivated the hearts and minds of astronomers for centuries. Welcome to the enigmatic realm of Saturn. The gas giant is full of secrets, from an artificially looking hexagonal pattern at its north pole to mysterious downpours falling on Saturn from space.
Beautiful
and
planet.
just recently, scientists noticed something weird was happening to Saturn's rings, which made them worry about our cosmic neighbor. In the very distant future, whoever inhabits Earth will not see Saturn's majestic rings.
Yep.
But why do astronomers think they're about to disappear? And what are these strange things moving along Saturn's rings?
This is cool. It's a cool intro.
The first close-up images of Saturn, captured by the Pioneer 11 spacecraft in 1979, marked the beginning of our journey towards understanding this celestial giant.
That's really
But
good.
it wasn't until the arrival of the Cassini mission in 2004 that scientists started to reveal the true wonders of this ringed world. As we continue studying Saturn, occasionally the planet unveils its secrets, demonstrating how much we still don't know about its intricate nature.
Oh yeah.
Saturn is the solar system's second largest planet, and it has a core about half the planet's radius, which weighs around 12 to 20 times the mass of Earth.
Really?
However, the amazing thing is that it would float in water if you had a big enough reservoir to hold it.
It's the
This
least
is because the
dense
gas
planet.
giant's density is about 0.687 grams per cubic centimeter, which makes Saturn the least dense amongst the planets of the solar system. But it's not just that. While most other planets orbiting the Sun appear as nearly perfect spheres, Saturn is the flattest of them all.
Really?
Its orbital period is approximately 10.5 hours, and it spins remarkably fast, which makes the gas giant bulge at its equator and flatten at its poles. The ringed planet measures approximately 75,000 miles in diameter at its equator and spans around 68,000 miles from one pole to the other.
Wow.
Saturn's distinctive yellow and gold bands visible from Earth are caused by superfast winds in its upper atmosphere that reach an incredible 1,100 miles per hour.
Wow.
But if you were to closely observe the sixth planet, you'd spot something truly bizarre. A colossal hexagon pattern, spanning about 20,000 miles in diameter. This awe-inspiring hexagon, with its immense proportions, might initially give the impression of an intricately crafted megastructure. Adding to its mystery, the pattern is transitioning from a bluish shade to a golden hue. Cassini's high-resolution images were carefully compiled to produce a breathtaking animation, revealing this phenomenon in vibrant color for the very first time. Within the swirling vortex of the hexagon located at Saturn's north pole, a colossal hurricane takes place in the middle, with an eye that surpasses Earth's hurricanes by a staggering 50%.
Wow.
Reddish vortices are scattered all around the hurricane. Together, they swirl in harmony with the counterclockwise
I'm kidding. We're actually great. We're really
See you
great.
guys after the ad.
Did you like it? Did you love it? Did you...
clockwise
Sorry about
motion
that.
of the
Here we go.
hexagonal jet stream. Inside the hexagon, there's a notable difference in the composition of particles compared to outside. Within the hexagon, smaller haze particles are abundant, while larger particles are scarce. And outside the hexagon, the situation is reversed. One of the most intriguing aspects of this six-sided storm is its resilience. While hurricanes on Earth last merely a week, this remarkable hexagon has endured for decades, or perhaps even centuries.
Yep.
So, how does a monster storm like this form?
How indeed. It's a good question.
A computer simulation revealed an intriguing phenomenon known as deep thermal convection. When heat is transferred through fluid or gas movement, it can generate atmospheric flows that result in the formation of large polar cyclones and an eastward jet pattern at high latitudes. As these atmospheric features combine near the planet's upper regions, they give rise to the unexpected and distinctive hexagonal shape observed at Saturn's North Pole.
Oh, wow.
And the hexagon's persistence is the result of all these storms forming deep within the planet, thousands of miles below the cloud tops.
Wow.
Scientists don't know of any other storm like this to exist anywhere in the universe. Saturn's hexagons are a demonstration of the wonders of our universe is capable of. But it's not the only intriguing feature the planet has to offer.
Sorry about the train, guys, if you can hear that in the background.
When looking through Voyager's data, scientists noticed something odd, mysterious spokes across the planet's rings. But then something even stranger was discovered. During the Cassini mission, no signs of these ghost-like features were detected, deepening the mystery behind this unexplained phenomenon. A closer observation revealed that the spokes generally have a dark appearance when viewed from above. However, when observed from below, they tend to appear bright. Researchers still don't know for certain what causes these mysterious streaks, but we do know that they re-emerge seasonally during Saturn's spring and fall. Just like here on our planet, there are 4 seasons on Saturn, but each of Saturn's seasons last approximately 7 Earth years.
Oh, wow.
The spokes are hypothesized to originate from dust particles in the rings that separate from icy chunks and float independently above the rest of the icy boulders. And it might be Saturn's magnetic field that causes this. When the solar wind interacts with Saturn's magnetic field, it creates an electrically charged environment. This environment can influence the behavior of the charged dust particles, making them stick together temporarily and form denser patches within the rings.
Oh, wow.
Although other giants in our solar system also have rings, Saturnian rings are the largest and most distinguishable. The 7 rings were named in the order of their discovery. Positioned along Saturn's equator, the rings begin approximately 4,300 miles from the planet's core and stretch outward for a staggering distance. The E ring alone encompasses a distance of about 75,000 miles to 260,000 miles. To give you a sense of scale, imagine a road extending across the entire length of Saturn's E ring, from its outer wisps to the inner boundary. If you were to drive continuously at a speed of 100 miles per hour, it would take over 2.5 months to travel from one end of the road to the other. And if you take into account the tenuous Phoebe ring, it extends approximately 100 to 270 times the radius of Saturn. Much like the distinctive shape of the planet itself, Saturn's rings are incredibly flat. Detailed observations indicate that while certain areas of the rings can reach a thickness of approximately 0.6 miles, the main rings are astonishingly slender, measuring a mere 32 feet in thickness. Saturn's ring particles have a wide size range, spanning from minuscule icy grains resembling dust to substantial fragments comparable in size to houses. And there are even a few exceptional particles that reach dimensions the magnitude of mountains.
Really?
But we didn't always know about Saturn's rings. Nearly 4 centuries ago, when Galileo first directed his telescope towards Saturn, he described the gas giant planet as having ears or handles, which were in fact the elongated bulges that we now recognize as Saturn's magnificent rings. With his modest telescope, Galileo could not discern the intricate details of the rings, leading him to mistake them for large celestial bodies positioned on either side of the planet. Today we think we know almost everything there is to know about the mighty rings of the 6th planet, but it continues to shatter our expectations. The particles within Saturn's rings, which are almost entirely water ice, are engaged in a delicate equilibrium between 2 opposing forces. Saturn's gravitational pull attracts them towards the planet, and their orbital velocity strives to propel them outward into space. Scientists have long wondered whether the planet evolved with its rings, and the latest findings show Saturn hasn't always had this peculiar feature. For more than 90% of the gas giant's lifespan, the planet had no rings.
Really?
So how and when did they form?
Probably.
One possibility is that the rings originated later in the planet's existence when small icy moons orbiting Saturn collided with each
That's
other.
what I was thinking.
These collisions might have been triggered by the gravitational influence of passing asteroids or comets. A 2016 study proposed another intriguing idea, that the rings could be the remnants of dwarf planets. This theory suggests that these dwarf planets, which met their demise in the distant past, now exist as the enigmatic rings encircling Saturn. Or it could have just been one large moon that collided with Saturn's largest satellite, Titan, in the past. Scientists have identified a potential moon called Chrysalis that existed before Saturn's rings formed. Through computer simulations, they found that Chrysalis was similar in size to Saturn's third largest moon, Iapetus. In the past, Saturn and Neptune's gravitational interaction caused the ringed planet's axis to tilt and wobble in sync with Neptune's orbit, leading to the changing angles at which we observe Saturnian rings. Titan exerts its gravity on the planet and moves away from it rapidly, while our moon also moves away from Earth, but at a slower pace. Around 100 to 200 million years ago, Titan and Chrysalis entered into a resonance, and as Titan migrated outward,
People everywhere. They're watching.
You ready for an adventure? Say yes, chef. Yes, chef.
Here we go.
the gravitational forces destabilized Chrysalis's orbit. That caused Chrysalis to approach Saturn and get torn apart by its gravity. Nearly 99% of Chrysalis was absorbed by the gas giant, and the remaining 1% left behind the stunning ring system we see today.
Wow.
According to a recent study, the age of Saturn's rings is approximately 100 to 400 million years, but their existence may soon come to an end. A true celestial marvel causes Saturn's majestic rings to melt away, and in another 100 or so million years, they will disappear. Under the influence of the sun's radiation or plasma clouds caused by space rock impacts, the dust particles of Saturnian rings sometimes become electrically charged and disturbed. When this happens, the dust particles bind to Saturn's magnetic field, which then draws them inward toward the gas giant's upper atmosphere. As the gas giant orbits the sun, the planet and its rings tilt, which changes the amount of the radiation output on its inner ring layers and affects the intensity of the icy ring rain. NASA says the sixth planet's ring system is depleting at an extremely fast rate. It's estimated that every 30 minutes, it loses an Olympic swimming pool volume of water. And just recently, after 4 decades of research, scientists have revealed the cascade of ring rain pouring down onto Saturn has an impact on the planet's atmosphere. Every passing second, an astounding amount of up to 6,000 pounds of icy particles previously bombarded by solar ultraviolet radiation gracefully descend onto the planet. As these particles make their atmospheric journey, their accumulated energy is transferred to the surrounding environment through collisions with other particles. This energetic exchange contributes to Saturn's atmospheric heating and may cause glowing bands in the planet's northern and southern hemispheres. But it's not the only rain there is on Saturn. Enceladus, a moon of Saturn, shoots jets of water ice into space from its underground ocean. Some of these tiny particles are influenced by Saturn's magnetic field and gravitational forces, causing them to rain down onto the gas giant's atmosphere. This phenomenon is known as the moon rain. Saturn's ring rain is a cocktail of chemicals, including some organic compounds. It consists of water, butane, propane, methane, ammonia, carbon monoxide, carbon dioxide, and molecular nitrogen. In the future, this cocktail could change the oxygen and carbon amounts in the gas giant's atmosphere. This alone isn't enough for any life to emerge on Saturn, but what about its moons?
Possibly.
Just recently, Saturn once again became the king of moons of the solar system. 62 new satellites have been found orbiting the ringed planet, which adds up to a total of 145 moons. But to scientists, particularly intriguing are Titan and Enceladus. Both of these satellites possess at least one essential ingredient for life. Titan is known for its thick atmosphere and abundant organic molecules, including complex hydrocarbons, which are considered building blocks for life, while Enceladus has a subsurface ocean of liquid water, making it a promising candidate for hosting life or supporting the conditions necessary for life to exist. Titan possesses a dense atmosphere resembling that of a planet. Similar to Earth, its atmosphere is predominantly composed of nitrogen. Additionally, Titan has rivers, lakes, and seas on its surface. However, unlike Earth's
Liquid
water-filled
methane
bodies,
and ethane.
Titan's liquid reservoirs consist of methane and ethane. Methane is a compound associated with the metabolic processes of many organisms, serving as a source of energy. Although it's highly improbable that the lipid-based membranes crucial for sustaining life on our planet would endure Titan's inhospitable conditions, such as its freezing temperatures of about minus 290 degrees Fahrenheit. However, scientists have proposed an alternative possibility involving a molecule called acrylonitrile. One of the unique properties of acrylonitrile is that it's potentially capable to form stable and flexible structures like cell membranes, forming a thin sheet-like material. This sheet could then shape into a small, hollow sphere called an azotosome. Similar to lipid bilayers, these azotosomes could act as microscopic containers for storage and transportation purposes. What's fascinating, the ALMA Observatory has detected significant amounts of acrylonitrile molecules in Titan's atmosphere, up to 2.8 parts per billion. Scientists believe an abundance of this chemical reaches the surface of the satellite. Throughout the existence of Titan, researchers calculated that Ligeia Mare, Titan's lake, could have gathered sufficient acrylonitrile to create approximately 10 million azotosomes in every milliliter of liquid. To put this into perspective, it surpasses the abundance of approximately 1 million bacteria per milliliter of coastal ocean water found on Earth.
Oh, wow.
Set to launch in 2027, NASA's Dragonfly drone will examine the satellite in depth and finally bring us closer to understanding whether life could form on such a celestial body. Until then, we might discover even more candidates for the existence of extraterrestrial life within our solar system. So stay tuned here to be updated on the latest breakthroughs in space exploration. We hope you enjoyed watching this video.
Wow. Okay. As always, that was really interesting. I knew obviously the rings of Saturn were spiraling in towards the planet because there's like a section or sections like certain distances from the planet in which if you're inside that certain distance, moons can't form and they spiral in towards the planet. If you're outside that certain, radius or section, moons can form, and that's how our moon formed, and they basically spiral outwards over time. I think our moon is moving away from us at like an inch or several inches a year, which doesn't seem like much, but over time it adds up. But yeah, I didn't know actually how Saturn's rings were depleting, and it's interesting to see that the sun has a lot to do with that. And what also intrigues me is that we always look for planets, Earth-like planets, extraterrestrial planets, and possible life on other planets. But what about the moons? There's literally hundreds of moons in our solar system alone that we could search for life. Maybe complex life, but maybe even microorganisms. That would be that in and of itself would be a breakthrough. But yeah, I think the moons would be a really good place, like Enceladus, Europa also has a frozen water ocean that extends for hundreds of miles deep before you get to the liquid layer of the water. Europa, I think, is the moon of Jupiter. Europa, Ganymede, and Callisto, the 4 Galilean moons of Jupiter. But the moons would be a really good place to look for life. But yeah, this was interesting. All right, if you want to see more, make sure to leave a like, comment, subscribe. Tell me what you guys think in the comments, and I guess I'll see you next time. All right, bye.